Bismillahirrahmanirrahim. Greetings. In this lecture, I'm going to share with you a few strategies for a better comprehension and problem solving in mathematics. Now, in the comment section below, I'm providing the site link of those lectures in which I have implemented these strategies and discuss them in much more detail. Now, at the end, I'm going to go over a very simple kind of a junior high problem, developmental kind of problem, to discuss a few words about contemplating, think and reflect, and also about critical thinking for that level. Okay, then let's get started, shall we? Now, the first is whenever you encounter with a problem that you haven't the faintest idea how to start. So you glance at it, you look at it for 5-10 seconds, and you don't even know how to start. So in that case, a good strategy is to make your own example, a familiar example, a much simpler example, and then see how you get the solution for that example, and then use that one as a prototype to get a jump start for the initial problem. Now let me make an example, or maybe one or two. Suppose a college has 100,000 student enrollment. They are consisting of freshman, sophomore, junior, and senior levels in the ratio of 4 to 3 to 2 to 1. Then they are asking how many of them are freshmen, or how many of them are sophomore or junior, etc. No, you don't know how to start, and it's too big of a number to sit and make a guess. So reduce the number of 100,000 to, let's say, 20, with the same ratio, 4 to 3 to 2 to 1, and then you know what will be the answer for yourself. If there are 20 students in that ratio, then you know that 8 of them will be freshmen. You know 6 of them will be sophomore. You know 4 of them will be junior, and will be two of them will be senior. And if you add all this, you will get 20. Do you follow me? And you can get them with the trial and error. Then, how did you get these answers? Where did you get them? You look for them, you solve it, and then you use the solution of that as a prototype to solve the hardest problem. You follow me? Now another example to make is that suppose we are given to add 1 plus 2 plus 3 up to, let's say, 100,000, or maybe 100 million or 100 billion to add them. If it is 100 billion, you need to live on Earth forever. It takes so long. You know how many seconds exist? If you can calculate how many seconds are in 1 billion, even if you do it per second, it takes you three times if you live on the Earth. So you know it's not practical. Huh? So what you do, the idea comes to you that can I change this addition into multiplication? Knowing that multiplication is a repeated addition. So you have to seek to some kind of repetition. So that is the idea comes to you. And the second, this large number, 100,000 or 100 million, reduce them to a smaller sample of your own. Let's say 10. All right? And then look at that, contemplate, and see what you see. 1 plus 2 plus 3 plus 4 and so on up to 10. You may notice that these numbers, 1 through 10, including 1 and 10, they are kind of distributed kind of evenly with respect to the with respect to the center line, imaginary center line, be midpoint between 5 and 6. Meaning that 5 of the numbers will fall to the left of that imaginary center line, which is 1, 2, 3, 4, 5, and the other 5 lands on the right of it, which is 6, 7, 8, 9, and 10. And then playing with them, as I have already mentioned, I have uploaded a more detail about that, about this, as I mentioned in the introduction. Now, playing with that, you end up changing addition into multiplication, and we come up with the formula of n times n plus 1 over 2. And in less than a minute, we could get the answer. The answer that could take us 3 lifetimes, we could get it less than a minute. Isn't that fascinating? So the other, so another strategy to discuss about is about kind of problem you have that there are data involved. So try to take information, the data, out of the given problem, and then organize those data through making a chart or a table, and then look for pattern. That is also very strong strategy for problem solving and learning mathematics correctly. And the last, I wouldn't say the last because there are so many other ones to discuss about. For these few numbers that I'm given, let's say, the last but not the least, but maybe the most important one, is that mathematics is foundation. The fundamental of mathematics are what? Definitions and theorems. And definitions are, all of them are if and only if statements. And they are given in a kind of condensed and short sentences. That is a little bit abstract, especially for the beginner students. So paraphrase it. Paraphrase the definition to your full comprehension. And but because they're if and only if a statement, so go first if, then look for the converse of that. And also the other thing to do to learn the definition very well is to learn it through an example of your own. So let the example to follow you to the full comprehension of the definition. Then definition becomes very sweet and understandable. Do not memorize it. Memorization is not learning. You may pass the course, even get an A in the course, but 2 days later you forget. So did you learn any mathematics? The memorization belongs to poetry and poem. Mathematics is neither poet nor poem. Mathematics has its own discipline, and you have to follow it in order to filter away the anxiety of that and bring joy for yourself. And then the other one is about theorems. What are theorems? Theorems, you can say they are kind of mathematical statements that they have been proven deductively, meaning that if the conditions given in the premises of the hypothesis, if they are honored and respected and follow, the conclusion of the theorem must follow. Do you follow me? So based on given premises, the conclusion must follow because it's a theorem. In other words, you cannot find a counterexample to contradict the theorem, not theorem. So but in order to comprehend the theorem very good, depending on how many premises are in the given hypothesis, try to take one at a time out. And now the conclusion may not follow. And then seek for counterexample. So to learn the art of paraphrasing, making example and making counterexamples, seeking for counterexamples are very, very important. Is the art of better comprehension and understanding mathematical subjects. Okay then, now let me go through a problem that I said in the beginning for the kind of junior level high school developmental mathematics. to talk about a little bit the critical thing. So I have one in the board. Let me zoom it for you if I may. Okay, let me cover this one. Suppose that we are given a problem 2 equals 1 over a square root of x minus 4, and they want us we solve it for x. What is the value of x? So look at that. Sometimes it's even multiple choice. So look at it. Don't be mechanical. Don't rush to do whatever you know in the past, a square both sides or what have you. Try to think. You know that x here, the value of that must be greater than 4. Why? So you know x cannot be 4. Why? You know x cannot be negative number. Why? So you look at that, that's the first thing you know. So if there is a multiple choice and one of the answer x equal to 4, you immediately say that is odd. And if the answer is one of them is negative, let's say negative 4 or negative 5, you know that is also out. So you are left with 2. Even if you don't know, you are not, you are in rush for the time, you can immediately select one of the 2 answers because 2 of them you eliminated, and now your probability is 2. Before it was 1/4, now it's 1/2. So very good chance you have the correct, you select the correct one. So that is one. Second one, let me see. I have asked some question here, and here, now the other thing to do is that look at 1 over this. The numerator is 1, is that right? So in order for this equality to hold, the denominator must be 1/2. Because 1 over 1/2 is 2. Alright, inverse of an inverse is the object. That is true in mirror image. Mirror image of an object is the original object in the original form. Again, I repeat myself, mirror image of an object is what is the object in its original form, in its original dimension. So 1 over 1/2 is 2. So that means this must be 1/2 in order the equality to hold. So you set this one equal to 1/2, then you go ahead and solve it. So square both sides, all right? You get x minus 4 equals to 1/4, and then you solve it for x. Do you follow me? Okay, now let me go to the next. Again, you are doing what? You are contemplating, you are thinking, you are improving your critical thinking toward that. You are not becoming kind of a recipe following, which is the worst. It's not really learning mathematics. Okay, now let's see. Let me check to see if it is zoomed. Yeah, it's good. Now here the same problem. The same problem is given to us, and what we do, look at this one. What do you notice? You notice that the numerator of this one is 1/2 of 2. You write 2, instead of 2, write it 2 over 1. You see that? So the numerator to the right-hand side, the fraction to the right-hand side, the numerator is 1. And 1 is 1/2 of 2. Therefore, in order to equality to hold, the denominator, which is the square root of x minus 4, must be half of the denominator about to the left. In this case is 1. So what is half of 1 is half, so this must be 1/2. So you set it equal to 1/2, and the rest of them we have already followed. We end up with solving and getting the answer. You follow me? So you square both sides, you add to both sides, and so on and so forth. You get common denominator and you're finished. Okay, this and the last one, let me go now over that. Now again, the same problem. Now in this case, what you notice, you know about ratio and proportion, huh? You know that the product of these two should be equal to product of these two if these two are in ratio proportion, if the equality holds. So that means this times this must be equal to this times this. And then you can make numerical example for yourself so that you feel comfortable in your heart. And then go ahead and set it up and solve it. Then you go ahead and square both sides. When you square both sides, A, B quantity square is not equal to A, B square. So don't try to memorize parrot like. If you are not sure, always make an example, numerical example of your own. If an example didn't work, immediately you know the generalization should be false, the way that you generalized it. So now look what I do. Here I'm squaring both sides, so it should be 2 square and this square. So what I made an example for myself so that I make sure. Suppose I have 2 times 3 square. I know 2 times 3 is what? 6. I know 6 square is 36. Is that right? So now, if I raise 2 to the 2, which is 4, 3 to the 2, which is 9, 4 times 9 is 36. Perfect. So I know the way I have done it is correct. But if you write 2 times 3 square, you know you do not get 36. You know the answer must be 36. So that is very important. You go and find your x. Okay, then let me go and zoom it back. Okay, I'm responding to some ads, and hopefully I may get, inshallah, a good college, a good place, and then I try to use the facilities of that institution for a better, videos. But I'm uploading all my videos, my channel is for the benefit of the public. First, for my own fellow American citizens, and second, for the rest of the world, whoever could really have benefit of that. I hope that these videos are beneficial to you. If you have any suggestion, or if you want any particular subject I give a lecture, I will be happy to do so, upload it. If it is beneficial to you, it will be beneficial to many other ones. Okay then, I thank you very much for watching. And as always, I wish you all prosperity and good health. And please stay and remain healthy. So long.